There were a few questions about like the long-term nature of things, right? Like how do I stay in here with the energy and the excitement and the passion, okay? So there's a few different answers to that question. Let me give you the most direct answer first. Bianca, when you asked the question, you were talking about like, I'm going to this very basic stuff, right? And you're right in a sense, of course, right? Because especially if you are the kind of person who, I'm into teaching this because the discipline itself is fascinating and amazing, and I want to dig down into the depths and the sophistication of this, right? It can feel like and now I've got to teach integers, I guess, right? Now, what I would suggest to you is all of mathematics is deeper and more sophisticated than you realize. And it's really just a question of, are you willing to find what that sophistication is? I'll give you an example that's not from the syllabus, and then I'll give you one that is, okay? Have you ever wondered why rainbows are round? You've thought about this? You've probably seen a rainbow thousands of times, and you looked up in the sky and you're like, yeah, it's the arch, right? If you're up very high, like if you're on, in a mountain, you'll actually see it's not a semicircle. It actually extends around. It's just the horizon gets in the way. If you're in a plane or a helicopter and you see a rainbow, you'll see it's actually the full circle. It's hard to see at the right time, but it's amazing. You can find pictures of it, right? It looks photoshopped. Why is it that? Why is it a perfect circle? What's going on there, right? Now there's some phenomenal circle geometry underneath that. Simple reality, but there's some really deep mathematics underneath it. So I would suggest, I guess the first answer to your question is, go and find what that deep mathematics is. It's often not there on the surface because in our subject we often focus on, can we solve a problem with this? Once you've got the algorithm, once you get the formula down, you like, great, I can solve this problem kind of without thinking. That's what formulas do, right? The quadratic formula is designed so that you don't have to think about completing the square, because completing the square is effortful. Quadratic formula makes it automatic, right? But what that does inadvertently is it kind of disguises, it masks some of the depths of understanding that can be there if you're willing to look for them, right? So now, let me give you a more syllabus example. When we say, hey students, do for me 24 divided by 8. You probably, as secondary trained teachers like me, just expect the students hopefully to know their times tables well enough to just say 3 and then you move on, right? You do, like you give it a tick, or you do with that answer whatever you needed, like factorize something out, or get common denominators for a fraction, etc. And then you move on, because it's just 24 divided by 8. What's the big deal, right? Answer, a lot. If you go and talk to our primary colleagues, what you'll find out is that there's actually entirely different ways of thinking about division. For example, think about this for a moment with me. What are you picturing in your mind when I say to you 24 divided by 8? If you could draw a picture of what 24 divided by 8 looks like, what would that picture be? Now, I'm gonna place bets that you've kind of pictured like maybe say 24 objects, right, in your mind, perhaps, and then you might be dividing it into 8 groups. You're like, I've got 8 people and 24 objects to share among the 8 people. That's what dividing is after all, right? And then you're like, well, they each get 3, happy times, move on. But that's not the only way to think about 24 divided by 8. Instead, you could say is, I've got 24 objects and I've got to make sure I get groups of 8. How many groups do I get? So then you have your 24 objects and you go 1, 2, 3, 4, 5, 6, 7, 8, one group. And then you go 1, 2, 3, 4, 5, 6, 7, 8, and then another group, right? These two different ways of thinking about division, you picture them quite differently, because one of them is 8 groups of 3, and the second way that I just described, you'll end up with 3 groups of 8. Now, that 3 groups of 8 way of thinking about things is where we get remainders from, right? Because you're like, oh, I've got some left over. 25 divided by 8, I had 1 remainder, right? But that other way of dividing up into, okay, I've got 8 groups. This is actually a whole different way of thinking about it. You don't get a remainder. You then have an extra one, which is like, oh, I guess all 8 of you, I'll have to slice this up. That's where you get 3 and an 8th, right? Which is a very different idea to a remainder, right? And we have names for this. The first kind of division is called partition. I'm partitioning 24 into 8 groups. And the second kind of division is called quotition. Quotition coming from quota. I've got to get to a quota of 8, and then I get to 8, and then I move on to the next group, right? Now, those mental frameworks for an idea as basic as division are going on underneath a student's mind. And so when you say to a student, do 24 divided by 8, I guarantee some of your students are going to draw 24 tally marks on the paper, and they're going to circle 8 of them and then circle another 8. And if you give them a question like 108 divided by 3, they are going to start drawing. And you think, hold on a second, what are you doing, right? It's because there's sophistication of this idea, which we as secondary teachers, because we don't teach division, we come after that. We assume they know. But spoilers, they don't always know. So I guess what I'm trying to say is, even the simplest idea has a lot in it. Fun fact, if you guys go and have a look into, I think it was mid-20th century, when mathematicians were trying to build the foundations of mathematics, and there's like a 500-page proof for why 1 plus 1 equals 2, and there's this lovely tongue-in-cheek comment just after the proof where it's like, finished, 500 pages, and then it says underneath, this result is sometimes useful. You can find depth in anything, and the challenge for you is to remain interested and engaged, find out what that is.